as you guys can see, I've combined the transition table and our initial introductory explanation diagram here. Our original state engine that we wish to create. Here's our JK schematic. So we have J0, K0, J1, K1, J2, K2, because we've got to figure out what to do with all the J's and all the K's to get the Q's to do this. That's the whole idea, summed up right there. All right, so we have to incorporate the transition table to be able to do that. I know I'm going to step in and out of frame of the camera, but hopefully you can still hear my voice. So we've got 4 statements to create 4 conditions to get us to get our expected Q outputs. So what we have to do at this point is we have to map out J, K for every flip-flop. So since we have 6 inputs, we're going to have 6 Karnaugh maps, 3 variable maps, because they've got 3 variables here. So I'm going to create a map for every J and every K. Small. So I move the camera up. What I've got here is I've drawn every table, or all the possible tables for Karnaugh maps, I should say. Alright, I've got everything on the board right now. This is just kind of overview. I know this is too small for you to see right now, so I'm going to zoom in on it here in a little bit. But first I want to show you that creating this and mapping the Karnaugh maps here is going to be a combination of working the state diagram and finding which statement on the transition table is going to apply so that we can properly populate the Karnaugh maps. Okay, just as a general overview, I hope you can at least see this. I've got 6 maps for 6 inputs. J0, K0, J0, K0, J1, K1, J1, K1, J2, K2, J2, K2. Now you need to have an understanding of Karnaugh maps. I will put a lesson together on that. I haven't yet, but I will. To be able to really work this. If you've never seen a Karnaugh map before, this can be a little overwhelming. You may still be able to work through it, but at a little bit of a disadvantage. So I've got a map for every input. What the map will do when it's completely filled out is it will tell me the sum of product expression or the product of sum expression based on grouping of the 1s or the 0s I will need to create the actual practical breadboard logic to get the transitions that I need to create the state engine. So I'm going to pause it and I'm going to zoom in on this map. You guys will need to have this transition table written down along with the 4 statements, because I'm going to refer to it constantly and you won't be able to see it on the video. So I'm going to zoom in here. We're going to start to fill out this table based on this and based on this. So you need to have these 2 things written down if you want to follow along. Otherwise you're just going to listen to me talk and refer to things that you can't see. So they need to be written down. Felt kind of bad about leaving you guys stuck out with nothing to refer to as I talked about this, so I consolidated the transition table, the 4 statements we got, to another table here. Okay, again, I'm going to scoot over here. The X's, you see X's on this table, this represents don't care states. They're very important. What a don't care state is when, if you look at the transition table, there were instances in where if J was a 0 and Q was a 0, Q after the pulse would remain a 0 regardless of what K is. That regardless means it didn't care what K was. It could have been a 0, it could have been a 1. The result was not based on K, so it didn't matter. We put an X to represent that. That X is going to transfer onto the Karnaugh map. So the 4 statements are transferred here. Go back and look at the transition table video if you need to understand how we got to these 4 statements. This table is based on that earlier video, so don't think I'm throwing new stuff. This is all part of one concept. Okay, so same JK tables here, transition table here, and this is our state diagram. I took it out of the circle so I can condense it for space. 0, 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 1, and then back again. All right, so now let's evaluate. All right, here's what we have to do. This is the J0, K0 table, and these will affect the outputs for Q0, Q1, and Q2. All right, so what we have to do is we have to see, okay, 0, 0, 0 to get to 0, 1, 1. what has to happen. All right, first Q0, and let me use my right hand. Q0 must go from a 0 to a 1. Okay, so which one on the transition table is going to affect that? Q0, we have to go from a 0 to a 1. There's a 0, oh sorry, a 0 to a 0. There's a 0 to a 1. So J has to be 1. K doesn't matter. Okay, so let's transition there. Q0 for the 0, 0, 0 state. 0, 0, 0. Q0, J and K. J is 1. K don't care. J is 1. K doesn't care. That will take Q0 from 0 to 1. Okay? Now let's look at Q1. 0 to 1. Same thing for the same map. 1x. Q2 is a little different. Q2 is a 0 before. It's going to be a 0 after the pulse. What transition will get us there? J is 0. K doesn't matter. Q was 0. It will stay as 0. So for 0, 0, 0, J is 0. K doesn't matter. Now, keep in mind, I'm able to figure out where these go because for this particular state, 0, 0, 0, where Q2 is 0, Q1 is 0, Q0 is 0, I follow that on the map. Q2, Q1, Q0, 0, 0, 0. For that state, 1x, 1x, 0x. That'll get me there. Okay? Next state, 0, 1, 1. So I find 0, 1, and 1. For J, 0, K, 0, 0, 1, 1. The Q0 bits up top. So 0, 1, and 1. And let's figure out what we're going to populate here, here, and here. Alright, so first off, Q0 has to go from a 1 to a 0, so it's got to go back. So here, let's see, Q was a 1 before the pulse, Q is a 0 after, K is 1, X doesn't care. Or sorry, K is 1, J doesn't care. X doesn't care. Alright, so we were at 0, 1, 1. J doesn't care. K is 1. So we're going to put that here. And an X for J, because that'll get us from a 1 to a 0 transition. Pause, check, make sure we're still filming. Keep hearing my camera click. Alright. Still filming, and we're back. Alright. So, I'm just going to walk this all the way through. We had a 1 to 0 transition here, or sorry. 1 to 0 transition, and now we need a 1 to 1 transition. 1 to 1. J is X, K is 0. I gotta find my place. J is X, 0, 1, 1. K is 0, 0, 1, 1. Boom. And then 0 to a 1 transition here. 0 was a 0, becomes a 1. 0 to 1 transition right here. J is 1. K doesn't matter. 0, 1, 1, J is 1. K doesn't matter because now I'm affecting the Q2 bit. I'm in the Q2 position. Alright. And final transition state, 1, 1, 1. We're going 0 to a 1 again. That's a 1x. So we're 1, 1, 0 now. 1, 1, 0 for Q0. Going 0 to 1 once again. That's 1x. Alright. And 1 to 1 here, we were a 1, we're staying a 1. Alright, 1 to 1 transition is here. J, don't care. K is 0. Sorry. Scratch pause, we got to get all the others here. And 1, 0. Okay, so 1, 1, 0. We were a 0, we needed to become a 1, so 1x. We were a 0, needed to become a 1, 1x. Now we got to go to the next bit. We were a 1, needed to stay a 1, so 1 to 1. J doesn't care, K is 1. So for 1, 1, 0, J doesn't care, K is 0. That's for our 1, 1, 0 for Q1. So 1 before the pulse, 1 after the pulse. Same for the next one. Q2, one before, one after. So that X0, we'll just transfer it right over here, X and 0, because the same transition is happening in Q2. All right, now we're at our final transition from our 1, 1, 1 state back to our 0, 0, 0. So 1, 1, 1, 1, 1, 1, 1, 1, 1, we got to fill all these in on the map. All right, so 1, 1, 1 to 0, 0, 0 is going to require a 1 to 0 transition every time. So we're going to be using this logic every time to get there. Where J doesn't care, K is 1. So K is 1, 1, 1, and J doesn't care, X, X, X. All right, so we mapped out everything that we need to do to transition through these states. I'll pause, make sure that we're still recording. And we are. All right, so now next step on the Karnaugh map is grouping. If you go back and look at my Karnaugh map lecture, you can figure it out, piece it together. I am going to work through it here, but if you don't understand the groupings and everything, this is where the disadvantage part comes in. You're not going to know why I'm doing what I'm doing. Alright, so I'm going to start grouping the Karnaugh map. I've got to group all my ones. I can't not group a 1. If I want the proper logic for the JK flip-flops, I've got to group all my ones to get my expressions. So here we go. And I'm going to use a different color. Use the blue. Use the blue. Up. I'm going to grab both of those. I'm going to grab as many as you can within the rules. Alright, so here are my groupings. Alright, and here's where the logic comes out. Again, you'll need to watch Karnaugh maps for that. Actually, what I'm going to do is, to get the logic out, I'm going to go ahead and clean this up, and then we're just going to start writing out the logic for J0, K0, J1, K1, J2, K2. Alright, so I'm going to wipe this now. Again, you did need a little bit of a background on the Boolean logic. Alright, but I'm going to work through it on here because I think I got a lot of space on my memory card, so we'll go ahead and work through it. Alright, J0 logic. Alright, we've got QZ, Q2, Q1, Q0. That's not. Well, that's going to go straight up there. We got to have that handed into J0 because that's a group by itself. So J0 is going to equal Q2, Q1, Q0, not ended together, plus, let's see what this expression is. Q2, Q1, Q0. That is true, not. And then Q2, Q1, Q0. That is true. So the Q0s will cancel. This will be plus Q2, Q1. J0's logic is an AND gate of Q2, or the inverse of Q2, Q1, Q0, plus Q2 and Q1. So 2 AND gates, 2 OR gates to fit that. Alright, K0 is going to be, let me write, nope, we got a grouping of 2, so let's simplify. Q2, Q1, Q0. That is not true, not true. Q2, Q1, Q0. True. There's my cancel. And that's my only term, Q1, Q0. Alright, that's all we need for K0, just to filter that in. 1 AND gate, Q1, Q0. Alright, J1 equals, it's only a 1 circled, so no simplification there. Q2, Q1, Q0, not. And then K1, Q2, Q1, Q0, true. And J2, let's see, that is, we're going to do this one first. We need to simplify because we've got 2 circled. Q2, notice I always write out my variables first and I go back and figure out what to not true. Keeps it easy in my head to work out. true, 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 cancel, Q1, Q0. Since I'm only circling the ones, I'm going to get sum of product expressions. That's why they're AND gates and not OR gates. If I circled the zeros, then I'd get product of sum expressions. So you can go either way. I like the sum of products. It's just what I got. Excuse me. It's just what I got used to. So that's what I do. Simplify, and then finally K2 needs to be simplified since we got a grouping of 2. Q2, Q1, Q0. Not true, true. Q, and the logic is going to be the same since we got it's the same for J2. I'm going to work it out just so you can see it. Q1, Q0, and it's true, true, true. Q2's cancel, so that as well as Q1, Q0. All right. Now I did rush through this somewhat hurriedly, so. You know, if you guys are watching this and notice or catch any mistakes here, just drop me a comment on the video as far as the mapping goes. You know, if I missed one or got on this map instead of the other, just let me know. I'll review it, validate it, and if I need to, I can add a caption or annotation to the video and just make that correction that way. Aside from that, we have the logic for all of the gates, J0 being the most complex one, where we're going to need 2 AND gates into an OR gate, basically, to accomplish this. They look a little funny because I'm drawing them vertically, but you got an AND gate here, you got an AND gate here, and then there's my OR gate, summing them together. Here, this is just a simple AND gate off of these 2 outputs. This is just another AND gate off of these 3 outputs. Of course, these would be the inversions, the Q naughts, of that particular JK flip-flop. This would be the AND gates here, or an AND gate here, another AND gate here, another AND gate here. So, theoretically, of course, assuming the Karnaugh mapping is all correct, we should be able to construct the synchronous counter design that we need based off just a series of AND gates or OR gates feeding the J and K inputs. Alright, that's as far as I'm going to take it. We can also create a schematic easily based off of this just by simply tying back to the outputs. But I want to go ahead and jump on that Karnaugh Map video, so I'll leave you with this. Any other questions or comments, just again drop them in the comment thread. They will come to my email. Thank you.